Today we are going to discuss about the potential energy. In last standard we learned that the potential energy means the energy stored in a body due to its specific position or place is called as a potential energy. This point already we have to study in a last, that is ninth standard. The definition of potential energy is the energy stored in a body, due to its specific position or place is called as a potential energy. So in this period we have to understand the gravitational potential energy. Gravitational potential energy we have to understand or discuss about. We know that if we throw any object from the earth's surface, immediately it can go in an upward direction, and then due to the gravitational force the object falls down attracted towards the center of earth. We know that. So gravitational potential energy, we know that in ninth standard P equal to formula mgh. M is mass of object, g means gravitation acceleration due to gravity, and h means height of the object. The formula for potential energy P equal to mgh. So look at this. For smaller distance, if we have to throw the pen in upward direction, the pen goes in a vertical in above direction, and after some time when velocity decreases, and then due to the acceleration due to gravity, the pen start to fall down. It goes attracted towards the earth due to the gravitational field for a small distance. But when there is a large distance, when we throw any object, initial velocity is greater or larger for a large object for a large distance, then we have to find the potential energy. The formula for potential energy P equal to minus gm upon r plus h, where for an infinite height distance from the earth, the value of g is 0. Look at this. If we throw any object which is an infinite distance from the earth's surface, then the acceleration due to gravity, the gravitational field becomes a 0. It does not attract towards the center of earth. When there is a infinite distance, when we throw the object at an infinite distance from earth's surface, then the value of g becomes a 0. At that point, the potential energy of an object equal to minus gm upon r plus h. So by using potential energy, the formula of potential energy for a infinite distance, P equal to minus gm upon r plus h, where capital M means mass of the earth and capital R means radius of earth. Next point we have to discuss about escape velocity. Look at this. Escape velocity. We know that most of the artificial satellite escape from the earth, and they does not back return to its return on the earth's surface. What is the reason? Most of the artificial satellite, all artificial satellite has initial velocity is larger. They escape from the earth. They does not return back to earth on the earth because initial velocity is larger. So the acceleration due to gravity or gravitational force does not return to the on the earth's surface. So artificial satellite has a different escape velocity. Every planet has a different escape velocity. So understand first what is the meaning of escape velocity. Escape velocity means the object which has initial velocity is greater or more initial velocity, then the object goes in a large distance from above surface, and at a point it can escape from the earth and does not return to back to the earth, then this velocity is known as escape velocity. So escape, for calculating the escape velocity, for finding the escape velocity, initial velocity always larger, always greater. If initial velocity is large, then the object escape from the earth gravitational field. They does not attract toward the earth. So first we have to define escape velocity. Look at this. The minimum velocity with which a body should be projected from the surface of earth so that it escape from the earth gravitational field is called escape velocity. So due to the escape velocity, artificial satellite does not back to the earth, does not falls on the earth, because initial velocity is greater, initial velocity larger, then they does not fall or return to the earth's surface. So the definition of escape velocity: minimum velocity with which a body should be projected from the surface of the earth so that it escape from the earth gravitational field is called escape velocity. पहा, escape velocity म्हणजे काय? एखाद्या वस्तूचा सुरुवातीचा वेग हा जर आपण जास्त ठेवला, सुरुवातीचा वेग जर आपण खूप ठेवला तर ती वस्तू जास्त वर जाईल. वस्तू जास्त वर गेली तर त्या ठिकाणी ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी म्हणजेच गुरुत्वाकर्षण कमी होईल. परिणामी या ठिकाणी अशा ठराविक अंतरावर ती वस्तू या ग्रॅव्हिटेशनल फील्डच्या बाहेर जाईल, अंतराळात जाईल आणि ती वस्तू पुन्हा खाली येणार नाही. मग त्या व्हेलॉसिटीला आपण एस्केप व्हेलॉसिटी म्हणतात. मग एस्केप व्हेलॉसिटी पाहिजे तर त्या वस्तूचा इनिशियल व्हेलॉसिटी, सुरुवातीचा वेग हा अतिशय मोठा पाहिजे. सुरुवातीचा वेग जास्त असेल तर ती वस्तू निश्चितपणे अतिशय उंच जाईल आणि एक अशा पॉइंटला येईल ज्या पॉइंटला ग्रॅव्हिटेशनल फील्ड अट्रॅक्ट करू शकणार नाही, गुरुत्वीय बल त्या वस्तूला खेचून घेऊ शकत नाही आणि ती वस्तू अंतराळामध्ये जाईल, स्पेसमध्ये जाईल. त्या व्हेलॉसिटीला आपण escape velocity म्हणता येईल. Then how we have to find the escape velocity? The derivation of escape velocity we have to be find as escape velocity आपण या ठिकाणी फाइंड आउट करू. Look at this. On the surface of earth, on the surface of earth, on the surface of earth, we know that kinetic energy equal to formula 1/2 mv square. ESC means escape velocity, 1/2 mv escape velocity square. Then B, kinetic potential energy equal to the formula of potential energy G m upon r minus G m upon r. Therefore total energy equal to E1 equal to kinetic energy plus potential energy. पहा, आपला कायनेटिक एनर्जीचा फॉर्म्युला माहिती आहे, 1/2 mv ESC square. ESC means escape velocity square. Potential energy equal to minus Gm upon r and TE equal to total energy E1 equal to Ke plus P. So we have to add these two energy. We get total energy, that is E1 equal to 1/2 mv escape square minus Gm m capital means mass of the earth, small letter m means mass of object upon r. E1 at an infinite distance from the earth. अंतर जर जास्त असेल पृथ्वीपासून तर त्याचं कायनेटिक आणि पोटेन्शियल एनर्जी आपण फाइंड आउट करू. at infinite distance from the earth, infinite distance असेल तर कायनेटिक एनर्जी 0, potential energy equal to also 0. Therefore total energy equal to E2 equal to 0. Then T1 from 1 and 2, T1 equal to E1 equal to E2 हे आपण सॉल्व करू. So therefore E1 equal to E2. E1 means 1 upon 2 mv escape square minus gmm upon r equal to 0. मायनस gmm upon r आपण राईट साइडला नेऊ, पॉझिटिव्ह लिहिता येईल. 1/2 mv escape square equal to gmm upon r. So m get cancel. Next point we have to write we have to write 1 upon 2 v escape square equal to gm upon r. 2 आपण इकडे ट्रान्सफर केलं तर मल्टिप्लाय मध्ये नेता येईल. v escape square equal to 2gm upon r. मल्टिप्लाय बोथ साइड वन, मल्टिप्लाय बोथ टर्म बाय r. दोन्ही टर्मला आपण r ने मल्टिप्लाय करू. v square vesc square equal to 2gm multiply r upon r into r. We get vesc square equal to 2gm r upon r square. We know that the formula of acceleration due to gravity g equal to formula काय gm upon r square. ही व्हॅल्यू आपण या इक्वेशन मध्ये सबस्टिट्यूट करू. वी गेट v स्क्वेअर इक्वल टू v esc v escape velocity square equal to 2 gm upon r square. यासाठी आपण व्हॅल्यू आपण घेऊ g, स्मॉल लेटर g into r. टेकिंग स्क्वेअर रूट ऑफ बोथ साइड, taking square root of both side, therefore vesc equal to under root 2gr. So the formula for escape velocity equal to vesc equal to under root 2gr. Escape velocity for earth is equal to earth equal to 11.2 kilometer per second. The escape velocity of a different planet have different escape velocity. So we have to understand the escape velocity point.